Hello everyone and welcome back to Arctic Retro. So in this video I'm gonna continue where I left off with this Commodore 128D, which I am building up from used parts that I have gathered through the latest couple of years. Anyway, in part 1 I left you with the motherboard. I have gone through what I have of the different parts and the plans for this project, and also I started to populate the board with the parts and other necessary components. However, since the board was in unknown condition, I wasn't sure if it was working or not, and our initial tests showed that it did not work. It just produces a black image on the TV. So I suggest you check out part 1 before you watch this. In this episode I'm going to try and figure out what's wrong with the board and see if I can fix it. Obviously I need to fix it if I am going to have a working Commodore 128D. Let me just take a break here and thank my sponsor PCBWay. And yes, PCB stands for Printed Circuit Boards. They are very friendly people, and if you head over to PCBWay.com, they can take care of all your hobbyist needs. Besides PCB manufacturing at the very reasonable prices, they also do CNC machining, sheet metal fabrication, 3D printing, injection molding, and they also have advanced high-quality PCB capabilities for your advanced needs. Right now they are hosting their 6th project design contest, and if you want to participate there you have to be quick because it ends pretty soon. You also need to check out their big Christmas sale that is going on right now. Now, before I start, I thought it would be interesting to see what happens if I hook up the floppy drive and start the machine, if it actually spins up. Yes, it does. It spins. But it does not stop. So definitely there's power to the drive. So the motor spins but the head doesn't move, so seems like it cannot initialize. That might be because of many things, and the black screen as well can mean a lot of things, ranging from RAM issues to, of course, some chips not working as they're supposed to. So just gonna start with that. I'm gonna use the oscilloscope and check the signals on some of the chips and the data and address lines and see what we have. Now, most of the chips on this board were there on the original board that I bought, and I don't know if everyone is okay or not, so that's what we're gonna figure out today. First off, I'm gonna check the 8502, which is the main CPU on this machine. This is a little bit more modern variant of the 6510 CPU, and it can run up to 2 megahertz, but otherwise it is quite similar. So just gonna start to see if we have a clock signal on that one, and the clock on this is pin 1. Yeah, that's a solid, nice clock signal. Yeah, so then we know the CPU is running at least. Then I'm going to check all the various data lines and the addressing lines. Start with the addressing lines. That's from pin 7 and downwards. Yeah, pin 7, and I just move down here and we should have a signal on all the pins down to 20. Yeah, that looks good so far. I can feel the set 80 is getting warm, really hot, hard to touch. Then we have pin 22 and 23 on the other side. Yeah, so all the address lines are good, seems like. Then the data bus, and that's pin 31 up to 38. Yeah, looking good, looking good. Yeah, all the lines on the data bus looks just fine too. Now checking the Z80 and it seems to be running fine. I have good signals on the addressing pins and the clock. So the 8502 and the Z80 CPUs both runs fine, and that means they are executing some form of code at least. However, why doesn't we have a picture? Well, I think then we need to check the VIC2 and see if it performs as it should. Well, let me first see if we have anything on the video output here. Yeah, there's definitely some kind of sync signal there. Alright, so this is the pinout for the 8566 week 2. Gonna check the data lines onto that chip as well. I already checked the color and sync and the clock, and that looks normal. Let's see the data lines. Yeah, looks good. 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 And the last one is on the other side. Yeah, all lines on the data bus just look fine on all the chips this far. So, next let's check the RAM, and these are the 4 RAM chips. These are MN41464 chips. Each of these are 32 kilobytes, so total of 128K there. And none of those are warm to the touch, so well, maybe that one is a little bit warmer than the 3 others. Yeah, same procedure, just hook up the oscilloscope and see if we have what we're supposed to have. Yeah, there's 5 volts at least. All 4, yeah. Now I'm gonna check the other signals as well. Just looking at the data sheet to see what the different pins are. Yeah, we have the addressing lines here, and yeah, all the other I/O and CAS and RAS. Yeah, and everything seems to be in order. Every signal is good and strong, and the same on all chips so far. Yeah, and I can't find any particularly things wrong with any of those chips by looking at the signal. Everything seems normal, healthy signals on all 4 chips, both in and out. So I checked the U9 here, which controls the CAS lines for the 4 RAM chips, and the signal out from that looks alright, so I'm gonna assume the RAM is okay for now. Anyway, even if there was a RAM problem, the diagnostics cartridge should be able to run, or the dead test cart. So there isn't any obviously wrong this far, and since it won't run from a cartridge, I'm wondering if it might be something with 8721 PLA. This is kind of special PLA for the 128. Alright, I took a little break, and then I did some inspection, and look what I found. I found one chip that this is an EEPROM. It was sitting there, but pin 1 is bent in. That needs to be fixed. Not really sure what this EEPROM is for. Could it be as simple as that? A pin not correctly inserted? I actually looked it up. U18 is the character ROM, but that did not help. I mean, without the character ROM you would see a picture, I think. So I really want to understand what is the matter with the machine before I start swapping chips. Since I have a working 128D, I can obviously start swapping some chips, and I'm gonna replace this one with the working one, see if that helps. Because this chip, the PLA, it's kind of difficult to figure out what all the different signals are and how they're supposed to be on and off. Well, that didn't turn out because it's obviously soldered in the other machine. I don't want to pull that machine apart, start desoldering chips and all that, but this 8722, it's in a socket in the other machine, so I can replace that one at least. Apply a little contact cleaner first. Here's the working one. At least it was working last time I turned on the other machine. It's been a while, you never know. Alright, look at that. We have some life in this board. I'll explain in a minute. I'm just gonna see if it runs through. All RAM is okay, seems. Let's wait for the SID chip. Yeah, loud and clear. Alright, so what I did, I swapped the wick and this 8701 and this one, and yeah, it didn't boot up normally, but with a dead test it actually started. So yeah, just need to figure out which of those chips were bad then. Yeah, in fact the diagnostics cartridge also runs, but as you can see there's a lot of bads because this is for the C64. Well, I don't know what happened, but the machine still works and I put back the original chips, so not sure what's going on here. So that's kind of annoying, but at the same time it's great. I mean, it could have been just some bad contacts in the sockets. Yeah, and now I pull the chips and put them back again. It works. However, it still won't boot without the cartridge, so yeah, there's still something here. I wonder if that's because the floppy drive is disconnected. I'm not really sure. I hooked up the drive and yeah, it's still the same. It just spins forever, but nothing happens. Alright, so we now know that the RAM is okay and yeah, wick chip is okay and we have video output, so that's good. However, what could be preventing this machine from starting? I'm still suspecting that PLA chip. However, I don't have a spare, and yeah. Well, I have a Commodore 128. Maybe I should open that and see if it's socketed. Here's a regular old 121, and luckily it has the PLA in socket. It is the same 8721 chip. I'm gonna pull that out. This machine worked, at least last time I tried it. You have seen it in one of my videos. I repaired it. I think I made a couple of videos, in fact. Yeah, let's try. Gonna jank out this one. I could, of course, try the reverse and see if this chip is okay in the other machine. If this doesn't work, try this first. Okay, let's see. Nope, still the same, so that did not solve the problem. But strangely now I get nothing. It doesn't want to run the diagnostics cartridge either. Try and clean the legs of the chips, and yeah, it was a little bit dirty, in fact. Well, that's kind of annoying. I checked a couple of other chips. I replaced the 8722 and the VIC chip from the other machine, and still no luck. I mean, something clearly happened. I could run the diagnostics cartridge before. Yeah, does it still have voltage on the chips? Yeah, 5 volts. So I even replaced the Z80 with a modern one, and it seems to be running just fine. Every signal is okay. Anyway, I think we need to go a little bit deeper. I need to use my oscilloscope a little bit more and check some more chips and see if things are normal. I mean, I took off the SID chip just to have it out of the equation, and the chips over here are for the floppy disk controller for the most part, so I'm not gonna check those. The 2 CIA chips, I think it's this one, one over here. I mean, they could be gone, but that wouldn't prevent the machine from booting, at least as far as I know. So I'm simply gonna take the oscilloscope, try and figure out, see if something is wrong with some other chips around here. Okay, so I am kind of stuck here. I have used the oscilloscope now all over the chips and everything looks normal. However, you don't know if the signals are correct. And yeah, I even tried to make a diagnostics ROM chip here, and I'm not really sure if this is for cartridge or not. I cannot start the machine from dead test anymore. It won't show the picture, so I don't know what's up with that. But when I try this, I've downloaded the binary file on simmers.net. There's a couple of diagnostics ROMs there, and if I turn the machine on with this in place of the kernel ROM, I get something on the screen. Looks kind of like that, but not much. But since there seems to be normal signal on all the major chips, no missing signals at least, as far as I can tell, I am gonna replace the RAM chips just to check if they're okay. They're not in sockets, so I need to desolder them first. Alright, let me desolder 4 RAM chips. It's a lot of work, but yeah, at least I get them in a socket. And I'll be back right after that. Damn, that was a lot of work. I think I used 1 hour to get those chips free. I used both the desoldering station, iron, wick, and at the end I used some hot air, but I finally managed to get those out. They were really stuck and short legs and bent on the other side, so yeah. So now I'm just gonna solder in some sockets. Well, before that I'm actually gonna test the chips, see if they're good. So I use this Chip Tester Pro. It's called the Retro Chip Tester Pro. And yeah, this is one I built myself from parts in a video a while back, and yeah, it's a very handy tool to have, and it supports a lot of different chips, and it is regularly updated. I mean, the firmware is updated with new features and support for new chips. So yeah, let's test. Yeah, testing the first one. Seems to be good. It does an extensive test, not only bit by bit, but different patterns. Yeah, that one passed. Okay, I'll keep that. Then the rest. Yes, and here we have a problem. It won't even detect the chip. Sometimes there can be a bad connection or something, but yeah. Tried several times, but seems like it doesn't work. Okay, put that aside. That one seems to work. Passed on that. Yeah, seems like it got test failed now. No, it was the wrong way. Okay, I tried again with the first one that was not detected, and now it works. I cleaned the pins on it. Now desoldering those chips took away a little bit of the solder mask and the silk screen marking, but otherwise it looks okay. I did not rip any pads. And now for some soldering. Come on, heat up. So that went well. Just a little cleaning here. Okay, I just want to test. I didn't do the recapping yet. First going to test if we see any difference in behavior with the RAM chips, the original in first. I'll insert the potentially faulty one there. So these are the ones that was in, and let's check now. Yeah, it's still the same. So let me try and replace that RAM chip. Now all the old RAM chips has really short legs. They have been cut after soldering. This one is new one, or yeah, probably not new, but looks new. Has long legs. Hey, look there. There's a change. And we can even see some characters. So that's a step closer. I'm gonna replace the rest of the RAM chips as well. I don't know what kind of brand these are. I can't even see it. Yeah, it says NEC on all four, and I probably got them on eBay from China, so they could be fakes, obviously. Alright, let's test. No, everything went black again. So I'm just testing that batch of chips, and in fact 3 of them was faulty. I got now 4 that was tested okay, 4 RAM chips. However, still back to a black screen. Alright, so this is getting wildly frustrating now. I have checked a lot more, and yeah, I dug a little bit deeper now and trying to study what happens when the machine starts up and things like that. The reset lines and everything seems to be normal, and the CPU, the 6510, when it runs, it should actually have a high on the ready, or at least a signal on the ready pin 2, and the AEC pin 5 should be high. Yeah, the ready signal comes in on pin 2, and it says here that the processor operates normally while ready is high. Okay, so it should be high. But the address bus, I think, are shared between the Z80 and the 8502, so should be perhaps, I think, a pulsating signal there, and the AEC on pin 5 should be high. That's the address enable control. The address bus is only valid when the AEC line is high, but both of those are low all the time. So I'm trying to trace back and see what controls those 2 lines. Yeah, it's not that easy to follow on a schematic that is split into several pages and is some places a little bit unreadable. But the AC goes through some control logic and then connects to the Z80 here on the bus ACK. And then the ready signal comes in on port 2 and is controlled by some logic, some AND gates, and then disappears out of this picture. It goes down here to the Z80 enable. So I need to figure out a little bit more about that and see if I can figure out what is wrong here. Nope, unfortunately this is not the machine. I just hooked up the working 128D just to have something to compare with, and indeed on pin 2 on the CPU and pin 5 I see a totally different behavior. If I check the ready signal on pin 2, yeah, you can see it goes up and down, so it's high and low. Yeah, now it's a little bit more clearer. So, and the AEC line, yes, you can see it's high, so this processor is running. And as I understand it from the schematics, those 2 lines are controlled by the MMU and the PLA chips in conjunction with the Z80. There's some Z80 enable pins on both of those chips. So let me check those. Pin 43 on the 8722, which is the MMU. It has a Z80 enabled. It is high, and on the 8721 it's pin 13. That's also high, so that means the Z80 is disabled because it's active low. Then the ready signal on the CPU is also controlled by the BA signal from the PLA, and the BA, I don't know if it is bus enable or something, but it's pin 21. Yeah, so that pulses, and on my faulty board that was high all the time, so that's the difference. So why is that? I just printed the 2 sides of the schematics, it's easier to follow. So the CPU is here, and the AEC and the ready signals are fed through this logic AND, and this logic AND gates here, this inverter, and it goes over to the Z80 bus ACK there. I checked all these gates, they are okay. Then it goes down here, and the one is going from Z80 enable, which is pin 43, which I showed you, and it was high, so the Z80 was disabled, and the other one goes over here to this BA, which has a pulse, but on the faulty board it is stable high all the time. So why is that? What is generating that signal? I tried with another PLA. It might be that the other PLA is also bad. I need to check that. Unfortunately, the PLA in this machine is soldered in, so I'm not gonna disassemble the whole machine and try and desolder it. Yeah, I think I have another Commodore 128 that is working. I'm gonna see if I can pull out from that one. Maybe it's socketed. Alright, so it's been a while now, and I am still trying to understand what's going on here. We know that the Z80 CPU is the one responsible for actually starting the main CPU, and that does not happen because we don't have any enable signal on the 8505. So I've been looking hard on the schematics. There's some Z80 clock coming in here. I don't know why there are 3 of these buffers for the same signal, but it eventually goes into here, which is the Z80, and also I was talking about the bus BA signal. And that one is coming into the PLA chip, and there is no signal, which there should be. So we followed that trace up here, and yeah, it's a little bit different, but it comes up to this 7407 hex buffer here as well, and it's U57. And I did some measurements on U57, and it doesn't look good up there. And I took the other machine and actually recorded what I see there, and now we're gonna compare this. Yeah, so I hope that there is something wrong there, and yeah, that's also connected. I think I'm gonna check the hex buffer here, which is U60, because yeah, some of these gates actually is on U57 and some on U60, so they have been mixed. So that makes sense that maybe the U60 does something wrong, or the U57. And U57 is here, and in fact this area it was a little bit problematic. I think maybe I had some lifted pads on this, which I thought I had fixed. And U60, it's the same chip, 7407 hex buffer. A hex buffer is just an kind of amplifier. It takes a signal in, and then it strengthens it and sends the exact signal out. So if you have a, let's say, a little bit weak signal in, let's say 4 volts, and the chip runs on 5 volts, then the output signal will be amplified to 5 volts. That also means that on every input pin we should see the exact same signal on the corresponding output pin. And that is not true for this chip. However, I don't know if all the pins on this chip is in use and how the traces are under, and it's a bit difficult to follow, but at least I tested this chip and it works in the Chip Tester Pro. Yeah, let me show you. It has some weird signals. Okay, so I'm gonna probe all the pins on this chip from 1 through 14, and we'll compare it to what I had on the other machine. However, it might be a difference after all, since the CPU hasn't even started to run properly, but at least we see if there's something totally wrong. Okay, so I'm just gonna quickly probe all the pins and compare it. So this is pin 1, there's nothing. Pin 2, there's nothing. Pin 3, there's nothing. Pin 4, there's nothing. Pin 5, there's some very low signal there, below 2 volts. That should be the same on pin 6. However, pin 6, there's nothing, and pin 7 is ground. 8, there's a signal. It should be the same on 9. It is. 10 there's a signal, should be the same on 9, there is, but a little low. 11, it's high. 13 should be high, yes, and 14 is 5 volts in, so that's correct. So definitely something going on that's not right with this chip. Now I tested the chip, as I said, it tested okay. I'm gonna desolder the socket, see if there's something wrong with the connections there and the lines going to it. And I really don't have a spare 7407, they're not much used, so I don't have anything to compare with except in the other machine, which I don't want to start desoldering chips from now since it's working. I'm also going to desolder the U60 since it's a 7407 as well, and I can swap them around, see if that makes a difference. I'm going to start with that, in fact. Time for a little desoldering. This is the chip. I'm not going to show you the whole thing because you've seen it many times. I'll be back when it's done. So the chip came out relatively stubborn. Problem with these chips is that the legs has been cut short on the other side and they are kind of bent to the side as well, so very hard to get out. But at least I tested it and it works in the chip tester pro. So yeah, I was thinking, okay, let's try and just swap those two chips and see if I get a different result on the U57. I'm pretty sure there's no difference, but I still want to test. No, in fact, it was the same. There's some weird signals on that side of the chip. So I need to desolder that socket and check out what's going on underneath there. Maybe there's a broken trace or something. I just noticed I soldered out this socket. One pin is missing. I did not see it fall out or anything. And it's not stuck behind in the board, so was it missing? I have no idea. Okay, so cleaned up and checked all the pads and traces from the chip on this side, and everything looks good. So everything apparently looks good here as well. I'm gonna check a little bit the continuity between the pads and the traces. Yeah, everything is okay electrically. Alright, in with a new socket, and this has all its pins. I really wonder if it was missing. I have to check back on the footage. Any case I didn't notice. Alright, both chips are in, and now I think definitely there's no more issue there. So let's actually test and see if anything happens. Nope, no luck on that. But it still has that below 2 volt signal on that pin, and yeah, maybe something else is keeping that low. I need to trace where it goes to. But it's so difficult because that chip is not pictured in the schematics as one chip. It's just the different symbols for the actual buffers that's used in many places, so it's hard to find them and to trace. But I'll take a look at it. Okay, so I've done a lot more checking and checking traces and signals, continuity everywhere, but nothing really comes up as a suggestion for me on what is wrong with this machine. So this is one of the most complex 8-bit machines you can have, I think, at least what I have been working on, and yeah. But this video comes to an end. I used a lot of time, so I think I will call this part 2, and then I had to think a little bit more, get some advice from someone or ask around a little bit and see if I can actually fix it in part 3. So if you have any suggestions, then please let me know in the comments below, and I'll be grateful for that. So thanks a lot for watching this far. I'm not really sure when the next part will come, but we'll see about that. Thanks a lot, and a special thanks to my patrons. See you all, bye bye.